equals the opposite over the adjacent. So the opposite is 100. The adjacent is b. Now, the reason you cannot use Pythagorean theorem is you don't know two of the three sides. Like, you are forced into using sine, cosine, tangent here.
Yeah.
Is that okay?
Yes.
All right. Now, do you remember how to solve this for b, or is that something we should go over here?
I'm trying to remember because I know I did something similar to this.
A couple options here. I wrote tangent 75 over 1. You can cross multiply here. That's one option. Okay, so it would be b times the tangent of 75 equals 1 times 100. Okay, so that ends up being just b tangent 75 equals 100. Now, the tangent of 75 is a number, like it's a numerical value. You can divide both sides by tangent 75. Okay, and that's where you go to your calculator. 100 divided by tangent of 75. Make sure your mode is in degrees. Let's see what you come up with.
So I got 26.79.
Okay, so we'll just say 26.8 for that. So we're just filling in this table back up here. All right, we found that B is 26.8. So a couple options to find C. Because you have two of the three sides, you can use the Pythagorean theorem. The other option is to use another trig function, sine, cosine, or tangent. There's not a right or a wrong here. Do you have a preference or something stand out to you?
No, I don't have a preference.
Okay, so we'll just use the Pythagorean theorem. So the you've got a squared plus b squared equals c squared. So we've got 100 squared plus 26.8 squared equals c squared. You take the square root of that. So you want to put that in the calculator. Don't try to use any funny algebra here. Just that's 100 there.
Yeah, 100 squared plus 26.8 squared. I got 103.5.
Very good. Okay. 103.5, like that. All right, so that does it for 32. You're going to use sine, cosine, tangent when you're using right triangles. I'm sure we're going to do more of these, but when it says solve the triangle there, they're indicating you need to solve everything in that triangle there. All right, so we'll move on to 42 here next. All right, so whenever you see some problems like this where there's multiple triangles, a good strategy is to break them apart. Like, look at just the one that's got the 60 and the 90 for now. Okay, and then we'll go back and find other stuff, but for now just go with that. There's two types of special triangles: 30, 60, 90 and 45, 45, 90. And we could actually do like an entire lesson on just special triangles like these. For today, though, I mean, we only have limited time, so we can't spend all our effort on that. But there's some formulas to do these. Now, you can also use your sine, cosine, tangent, and that's where I guess I'm wondering, did you guys talk about 30, 60, 90, or did you just been doing sine, cosine, tangent?
Oh yes, we talked about 30, 60, 90 just a little bit.
All right, so let's not use 30, 60, 90 because it'll take us away from our lesson emphasis too much. Again, kind of relative to that 60, you saw me draw the stick figure there. What is the 85? Is it again, it's opposite, hypotenuse, or adjacent? Which one is it?
It's opposite.
It's opposite. Now, I'm telling you we want to find, and I'll just call it B. We want to find B, so we're going to use tangent again. Okay, so the tangent of 60 degrees equals 85 opposite over adjacent B. Is that okay? Opposite over adjacent, just putting the numbers in or the letter.
Yes.
And we'll get to why we're doing that in a moment, but for now, let's just be okay with that.
Right.
Although I'm looking at this now. Well, yeah, I guess that's okay. All right. So go ahead and solve that for B. It's just kind of just like the last problem, just different numbers. We're just round to maybe one decimal place.
Yeah. I got 147.2. I don't know if that's right.
So I've got a different result here. What did you put in the calculator? Could you tell me verbally?
I did 85 times tangent of 60. I don't think I put it in right though.
Okay, so let's go back and look at the previous problem. The previous problem, see how we divided both sides by tangent?
Yeah.
It's going to be division this time.
Okay.
Just like this one here.
So then I got 49.1.
Yes. So B is 49.1. Great. Now I mentioned like there's multiple triangles here. Sometimes I have those on the certain games. Like how many triangles do you see? You only care about right triangles. That's why we drawn this smaller one. Do you see a second right triangle in this picture?
No.
So how about the large one?
Oh, I guess. Yeah.
Okay, so that it's not really a math skill. It's just a like comfort level with doing problems like this. This time we want to find the whole base here. Now I'm going to use a different letter. I'm going to use I don't know, W, just because I want to use a different letter. But W represents the whole bottom here.
Yeah.
And you can find W just the same way we found B in this previous part of the problem. Will you try doing that for us, please?
Yes. So it's going to be, let me see, 121.4.
Okay, tell me what your setup is.
I did, oh shoot, I put the wrong number in. Hold on, let me do that again.
Okay.
85 divided by tangent of 30.
Yes, that's correct.
I accidentally hit 31 with my finger.
I'm actually surprised it made that much of a difference, but yeah, go ahead when you got the number.
147.2.
Yes, yeah. So W is 147.2, doing the same approach. Now we're interested in X. The whole bottom here is 147.2. We know B. To find X, you subtract 49.1 from 147.2. So X, I mean, a couple ways to do it. You can say B plus X equals W, and then W is, I'm sorry, X is W minus B. 147.2 minus 49.1.
Yeah. So that's 98.1.
Yes. Now there is a way to do this problem without sine cosine, but you'll want to maybe just check in class and see if it was done by hand, meaning without a calculator, because there is some special triangles you can take care of.
Yes.
All right, 43 is next. All right, so I kind of stepped you through the last one. Our ultimate goal here is to find x, okay? So to find x, if we look at that triangle there off to the right, that right triangle to find x, we either need this base here or this leg here or leg here. Like we need one or the other. Would you agree with that?
Yes.
And we don't have them, but we've got this other triangle, and I do recommend splitting them apart. We've got this other triangle, and we know this leg. So can we find this hypotenuse to find this leg? Like do you see that they're the same? If we find the hypotenuse, it becomes the leg of this other triangle.
Yes.
Okay. So again, it goes back to like, okay, you're given an angle, you know, relative to this angle right here, what do you have and what do you want to know? And that tells you whether you're going to use sine, cosine, or tangent.
So would you do sine of 60 like equals 50 over x?
Yes. Let's not use x though. Let's use c, because
Okay.
x is the thing we're trying to find.
Yeah.
But yeah, good setup there. So go ahead and solve that for c. We're gonna we'll go to 2 or 3 decimal places this time, just because it's an intermediate result.
So 57.7.
Yes. So c is 57.7. So that's right there. And again, kind of just like the last problem, it's like, well, if you are here, you know, you have the opposite and you want the hypotenuse, which do you use? And it's the same. Sine of 65 equals 57.7 over x. Solve for x.
And that's 63.7.
Yes.
So then that's just your final answer.
Yes. Yes. So these problems are the 2 problems we've been doing. You always want to think of them as like terms of like, well, I want this, so what do I need to know to find this? I need something else. How do I find that intermediate piece? And you do this all the time in real life, but in math, it's sometimes just different for that. Any other thoughts or questions, comments till we move on to 49?
No, I think I'm good.
Okay, so 49, and most of these story problems here, word problems here, they do not have a picture. They're just words.
Right.
All right. And now what section, just, and it's kind of an obvious question, but what section of the book are you in right now? Like what have we been doing the last 20 minutes? What kinds of problems?
Like what they're like called.
Yeah, don't overthink it. Don't overthink it here. What kind of triangles have we been working with?
Oh, like right angle
Right.
triangle.
Right triangles. Yes. So like what I want you to do here, and this is hard, but I want you to try it out because you're going to need the skill in the test, is I want you to make a drawing. Now it should have a right triangle in it. Like, I don't know, and I'll ask you some questions after you draw it, but basically I want to know if you've put some of the information incorrectly or all of it. That's because if I draw the triangle, that doesn't help you. So take an attempt. Now this is probably not the best problem because it's a laser beam, it's the moon, it's the earth, but it is a right triangle. So take a minute, see what you come up with, and then I'll jump in and help if needed.
Okay, I think I've got it.
Okay. Uh, Now, are you one of those people that believes we went to the moon? I mean, that's what I believe, but I'm just gonna throw that out there.
Yeah,
Okay.
I think I
Okay.
believe that.
All right. Every once in a while, I meet a student who's like, oh, I'm not sure we actually went there. Uh,
I know, like people always say that they're like, no, it's just staged.
yeah, I don't know. It's a lot of effort. So here is kind of if you want the drawing with like the Earth and the moon, not to scale. But the idea here is that if it was shot straight, you would get you would do this horizontal line, but it's not. It's this other thing here. So sometimes you draw the picture and it's not really to scale. So did you draw something like this, more like this one, or more like this one on the left or the right? Neither are wrong. I'm just asking.
I had I had two circles connected to the end, and then I kind of drew like kind of how you drew like the circles connected, except the triangle is more like a triangle. It's not like a straight
Okay.
line.
Okay, but does it look more like the one on this triangle on the left or this one on the right?
Probably on the left.
Okay. Okay. So it says here it's 0.5 degrees right here. And the distance from the moon is 240,000 miles. Okay, so
Yeah.
does your triangle, is it labeled at all like this?
I put the degrees, but I forgot to put the 240.
Okay. And the question is asking how far has it diverged? So it's this height here is what we're trying to find. That's the last little piece.
Yeah.
On there. Okay, now this one's really tough because you probably aren't used to seeing problems with laser beams. They're like the ladder problems, the height of a tower. Those are going to be more standard problems. Things like that. Okay, so we want to solve for the leg of this triangle. All right,
Okay.
and we're given the angle and the adjacent side. What trig function should we use given that information?
Probably tangent.
Tangent. So it's the tangent of 0.5 degrees equals b over 240,000.
Okay.
Okay, so this one's different. To solve for b, you just have to clear out the fraction, meaning you multiply both sides by 240,000. So go ahead and calculate that for us, please.
So I got 2,094.45.
Okay, yeah, 2,094. So the idea here is like if your target was there, you missed it by 294 miles, 2,094 miles.
Yeah.
Okay, and that could be a lot. Like now the question is, well, is the moon large enough for that to matter?
Mm-hmm.
And so that's where it's going in part B. It's basically saying like, is that
possible?
like would it have still hit the moon? So the idea here, here's the moon and it's a circle roughly, and it's a radius of 1,000, but you missed it by 2,094. So did it strike the moon? So is it maybe it's not clear.
Can you hear me?
Yes, now I can.
Oh, sorry, that was weird. My thing wasn't working. Okay, sorry.
So my just to reset it up here, my question was the radius is 1,000, but you're off by 2,000. Does it strike the moon?
So the radius is 1,000, but you're off by 2,000.
Yeah.
So then it wouldn't hit the moon.
It would not. It would miss by that.
Yeah.
Do you play any? I know you play volleyball, golf, tennis, any sort of sports like that, maybe baseball.
I know a lot about baseball.
Okay. So the difference between a ball that is goes over the fence and a pop fly sometimes isn't very much in terms of that angle. Like it's very fractional, but it's because of how fast the bat's being swung. So the point here is like while half a degree might not seem like that much to us, spread out over 240,000 miles, it's quite significant.
Right.
Any questions on that before we move on to the next problem?
No.
All right, so let's move on to, let's see here, 50. Okay. All right. So again, just like the last problem, I'm going to ask you to make a drawing. What I'm really asking for is a triangle with the correct labeling, not necessarily the orientation of this. And if you're really not sure, that's fine, but I would like to just see an attempt here. But the only thing, I guess I should ask you this first, and I'll maybe cover that. Have you heard of angle of depression before?
Yes.
Okay. So I'll just quickly describe what angle of depression is, even though you say you've got it. The angle of depression is this one here.
Mm-hmm.
Okay, it's from the horizontal, but it's as if you're going down. It is the same as the elevation, but it's depression kind of when you're looking down.
Right.
So like that. But in terms of the triangle, you would typically label it down here in the other position.
Yeah. So like if the angle of depression is like 23 degrees, the elevation is also
Yes,
23.
they're congruent. Yeah,
Okay.
just kind of interesting. Let me know if you've got a drawing or want to make questions.
Yeah, I think I have it.
Okay, so it really depends on whether you want your lighthouse to be on the left or your lighthouse to be on the right, because it's either this triangle or it's a triangle like this. Which one did you end up going with?
I had the one on the right.
Okay. And there's not a wrong answer here because they don't give it to you. They don't say, specify. So this time, like we just talked about, that it's 23 degrees there, which makes this one down here 23 degrees, right angle. And then they're telling you it's 200 feet tall. And then you're asked to find, and I'll just call it X this time for horizontal. Does that match what you have?
Yes.
Okay. So this is the hard part. The hard part really is like getting the drawing correct. Like if it were me and I had a teacher that was willing, I would go up and ask them, hey, is this right? Because everything you do from here, if this is wrong, you will get the wrong answer.
Right.
All right, so just like before, relative to this angle, you have the opposite and the adjacent. I want you to set up your trig function and solve for X.
Okay. So you'd be using tangent.
Yes, I agree.
So would it be 471.2?
Yes. Okay, and that's it. There's nothing more to do. You probably should put units in. Let's see here. Did it say feet? Yeah, feet. That's kind of important. These numbers don't necessarily mean much because I'm not sure if you have a great understanding, neither do I, of like what 23 degrees actually is. So it's not like you can get a result and be like, oh, that seems right. You kind of just have to trust the steps when you're doing this.
Yeah.
All right, that's 50, 51. All right, the ladder problem. What's really interesting is the way they draw the ladder problems. To me, is really interesting. We actually never visualize, at least as far as I can tell, a ladder leaning against a building. Like if you visualize a ladder, it's usually straight on, as if like you are about to get on it. But the way they want you to draw the ladder problems is either where this is the ladder here as the hypotenuse, or if you prefer the other direction, the ladder here is on the hypotenuse and it's the wall and the wall.
Mhm.
So either one of these, go ahead and set it up whichever way you see, and let me know when you've got a drawing here for this.
Okay, I drew the one on the left.
Okay, so I'm gonna do something a little bit different this time. I'm gonna label this A, B, C, C, B, and A, and I want you to tell me what you know and don't know, or tell me what you know, I guess, starting in this drawing.
So 20-foot ladder should be C.
Little C, good.
Yeah. And then the angle of the angle for a big B is 72
Very good,
degrees.
very good, very good. Okay, and what are you trying to find? What is it asking for in this problem?
It's asking to find how high does the ladder reach. So um is it little b?
Yes, yes. Now, could it also ask like how far away from the wall does the ladder stand?
Yes, it could ask for little a too.
It could, but it doesn't, so we don't have to find it. All right, well, you know enough to be able to solve this problem, sine, cosine, or tangent. Let me know when you've got an answer. Let's round it to one decimal place. Don't forget your units of feet, but give this a try, please.
Okay. I got 19.02.
Okay, so we'll call it 19 feet.
Yes.
Now, is it possible for a 20-foot ladder to be more than 20 feet against the wall, or the height of the wall?
No.
It's not. And same thing down here as well. Like you couldn't somehow
Right.
get that. Good.
Yeah.
Good. Any questions on that?
Mm-mm.
All right. So 52. I'm not gonna jump in here and draw the picture. I want you to try your best. It is a right triangle of some sort. So go ahead and see if you can draw that and let me know when you've got a picture. Don't worry about this idea that's a guy wire. It's literally a wire from the top of a building to the ground.
Yeah. Okay, so I used sine.
Well, actually, hang on. Just let me draw it here. Did you draw a triangle like this one or the other one?
The other way.
This way. Okay.
Mm-hmm.
All right. And let me just look back here. Let's see. You did that. I'm trying to look back here. You may want to try drawing the triangles in the same orientation each way. It looks like you do have a preference for this one on the right. There's not a wrong answer, but you're going to move into a part of the course where you will want to draw the triangle. Correct. So the same orientation each time, not correct.
Yeah.
Does this match what you're labeling?
Yes.
All right, now for height, you could go H, you could go Y. I agree with sine. Did you say you have an answer already for this?
Yeah.
All right, give me just a moment to calculate it. My end. All right, go ahead. If you got it.
I got 543.8.
What are the units of that?
It would be feet.
Feet. So all of a sudden in math, units matter. Just be very aware. Your teacher may grade you very harshly on that if you don't play the game of getting the right units in there.
Yes.
Oh, 57 refers to a previous problem. Lovely. So 57 refers to 56, which is cut off. I don't know if you can quickly send over a picture of that by email. We can do 61 in the meantime.
Yeah, we can. I mean, how much time do we have? What time is it?
I think we got plenty of time to do both. We'll definitely do 61, but what I need is a picture of 56 since 57 refers to 56.
Let me see. Oh, it is cut off. Okay, I'll send a picture. Let me go get a picture of that.
Let me know when you're back.
Yes, it should be. It's loading, so it should be sending in a second.
Great. So let's go ahead and start this problem here. They really reach here. I mean, they're trying to. I mean, it's a right triangle problem. They're going to give you, a side and an angle, and really, it's just about you coming up with that information here. And it doesn't have to be drawn to scale, but when we look at this, it says the moon is exactly half full. The Earth, moon, and sun form a right angle. I assume that's true. I don't have any idea. At the time, the angle formed by the sun, Earth, and moon is measured to be 89.85 degrees. So there might be this question of like, well, which angle is it? Well, it's definitely not the right angle. And you can tell this one's pretty acute here. So that's probably this other one here, kind of by process of elimination. Okay, but again, if you're not sure, you can do it. Then the last part says the distance from the Earth to the moon, again, not really to scale for maybe what we think is reasonable, but that's probably true. It's 240,000 miles. And then we want, what do we want? Well, estimate the distance from the Earth to the sun. So we want C. So sometimes you look at a problem like this, you think it's really difficult, but again, they're going to give you a side and an angle. You got to figure out which trig function you're going to use, sine, cosine, or tangent. I think we finally get to use cosine in this one.
Right.
So go ahead and calculate that. Let me know what you come up with.
I got 91.7.
91.7. Sorry, I'm looking at my answer, and my answer doesn't make sense either. Let's see. Tell me what you did here. How did you set this up?
So I don't know if I plugged this in right. Is it 89.85?
Okay, so your answer is correct. You're just not reading off the E part.
Okay.
So it is 91.7, but it's times 10 to the what power?
To wait, I'm confused on.
Your answer is correct. It's 240,000 divided by the cosine of 89.85. But your calculator has like a little e, or it says 10e to the
Okay. Let me go
3.
back and do it again.
Yeah.
So it was sine two. What did I do? 240.
Cosine. You use cosine.
Oh, right. Oh, okay. Oh, wait. Now I got a different answer. Cosine of 89.85
Yes.
times 240,000.
No. So you're set up. You had it right. I didn't realize that you were not seeing, but it's cosine of that angle equals 240,000 divided by C.
Okay, so it was okay. I got 628.
You're solving for C. So just like you did before, you have to move C to the other side of the equation, and then divide by the cosine of 89.85.
Oh, okay. I don't know why I like did that wrong. 2, 4.
Do you have an answer?
Yeah. Okay, so wait, now I'm getting like a big number, maybe like
Yes.
916.
That's right.
Like,
That is correct. It's
yeah.
so it's
9167351.94.
yes. That's your answer.
Oh, I just moved it. Okay. I see.
Okay, let's move to the previous problem here. 57. An airplane is flying at an elevation of 5,150 feet directly above a straight highway. Two motorists are driving cars on the highway on opposite sides of the plane, and the angle of depression to one car is 35 degrees and the other is 52 degrees. How far apart are the cars? So setup here is there's an airplane right here, and there's a car over there and a car over there. Now, if you drop an altitude, this makes two right triangles. Okay, now because we're going to do 57, they're saying to change the angles to 52 and 38 degrees. So you have to draw in that this is, well, I'll just pick this is 52 degrees. This is 38 degrees, which maps to 52 degrees and 38 degrees. Is that okay?
Yes.
Awesome. All right, now, do we care about do we know the height? Or do we care? Do we know the height?
No. Oh, wait, yes, we do. 5,150.
Yes, yes. You got to be careful that you actually know what you're given and what you're trying to find. So in both triangles, the height's the same.
Yes.
And you can find, I'll just call this B and this X. You can find B and X using sine, cosine, or tangent for each one. So I want you to find B first. Go ahead and find B, calculate B using sine, cosine, or tangent. And then we'll calculate the other one.
So cosine of 38.
You're not going to use cosine. Cosine would be true if you wanted to find the adjacent and you had the hypotenuse. You have the opposite and the adjacent.
Okay, so then it would be tangent.
Yes.
I always get confused on how to set up. Is it gonna be 5,150 multiplied by tangent 38?
So you write it as tangent 38 equals 5150 over B. And then from here you decide how you're going to solve it, which is to move swap positions.
So you're gonna divide.
Yes.
So then it would be 1.52.
Nope. So again, that number is really far off. I mean, it can't just be. So how did you solve this for B?
Oh, wait, I got 6,591.
Yes, that's better. 6,592. We're going to do the same thing for the other one. Tangent of 52 equals 5150 divided by X. We should have spent a little more time on the solving. I regret that we didn't do that, but we can do that next time if needed. So that ends up being 4,023 when you solve for it. Just because we're running out of time here, I'm just going to jump in. But it wants the total distance. So it wants to know how far apart the cars are, which means you're going to add the two values. You're going to add B plus X.
Okay, so 6. Plus 4. So I got 10,615.
Perfect. And then probably feet. I think it says in feet. Units are really important. All right. Well, we got everything done for today. Good job.